Hello, can you speak heat pump? Do you know all the jargon? Do you know the key words? Do you know your way around? Today in the Happy Heat Pump podcast, Beanland and I are going to explain some of the terms. Actually, that's not true. I'm going to say what the terms are, and Beanland, the great aficionado of heat pumps, is going to say what those words mean, so you will be fluent in the language of heat pumps. Are you with us? Great. Bean, let's start. We've done one or two of these before, but I think we should do it again. I think you should not take more than 30 seconds on any one of these terms.
Okay, speed dating. Right.
Coefficient of performance. COP, C-O-P, coefficient of performance.
Instantaneous ratio between the amount of electricity going into a machine and the amount of heat coming out the other side.
So, for example,
instantaneous. So 1 kilowatt hour of electricity in, 3 or 4 kilowatt hours of heat out into your heating system or your hot water cylinder.
High number is a good thing. You want it to be as
the
high
higher
as possible.
The higher the COP, the better.
4 or 5 would be great, and that would be a kind of nice efficiency measure.
4 plus would be very acceptable.
I saw a comment in one of our YouTube videos that said, COP, C-O-P, is a term people are starting to understand. I'm not sure. Nothing worse than down the pub when two heat pump owners get together and have a contest on who knows most and who has the best COP. Okay, coefficient of performance. Next, seasonal coefficient of performance.
Yeah, so this is the seasonally adjusted average over the 12-month period. So COP varies all the time, depending on outside air temperature, the flow temperature required in the radiators, a whole number of external factors. So the COP is moving all the time, which is why we say it's instantaneous. Seasonal coefficient performance is 12-month adjusted. I actually usually prefer to refer to it as seasonal performance factor, SPF, which is a ratio annually between the amount of electricity you use and the amount of heat you get out of it.
Okay. So again, a high number would be a good number.
Correct.
You're getting more bang for your buck.
Yeah. 1-to-1 is an immersion, effectively.
Yeah.
So, getting well above immersion is the answer.
Yeah.
And it's perfectly possible in the UK to achieve, high 3s, 4s routinely. We should be achieving that. So our industry needs to, look at itself sometimes and say, why aren't we routinely delivering better numbers? We should be.
Okay. I was going to ask you the next one was going to be SPF, heating seasonal performance factor, but that's basically the same as seasonal coefficient of performance, essentially. SCOP and SPF. Isn't SPF what they use on the sun lotion ones? Isn't it sun protection factor?
It could be.
Okay, two very basic ones, and I think
I don't go out in the sun. I wouldn't know.
Two very basic ones coming up now, but I want you to just define them so people who may be joining us late can keep up with everything. Air source heat pump.
So, we normally refer to heat pump devices by the source and the method in which we deliver the heat. So, air source, we should really be saying air to water heat pumps, because the source is the outside air and we're delivering it via wet systems, radiators, underfloor heating, so air to water. Air to air, what most people refer to as air conditioning, we're still harvesting the energy from the outside air, but we're delivering it by blown air into the building, into the room.
So an air source is one that sources it outside in the air.
Yep.
And it will come in the form of air to water, which is through your radiators or underfloor heating, or air to air, which is going to blow a nice fan on you.
Yep.
Next, ground source heat pump.
So there we're harvesting naturally stored solar energy in the ground, and we could have ground to water. We could actually have ground to air, incredibly rare, but ground to water is the most common portion. So we tend not to say to water because there's an assumption there that that's how you're delivering in the UK because of our obsession with hydronic systems.
Right, so air to air and air to water, you would generally specify how you're burning it.
Yeah.
Ground source, you would normally just say where it's coming from. But there are two forms of ground source heat pump, aren't there? Or more than two. Come and just give me a few.
Yeah, so there are multiple ways of harvesting the energy from the ground. So we can go out horizontally.
Big network pipes under the ground.
An array of pipes under the ground, and those can be laid in different configurations. So there are various ways of configuring that pipework in the ground. Alternatively, if we're short on space horizontally, we can go down vertically. And the depth to which we go down vertically is a factor determined by the amount of energy you need, the thermal properties in the subsoils and in the deep geology. Could be any number of things. If we're building piles, we might only be down 15 meters. If we're using deep probe-driven piles, so we're drilling deep, putting in what we call probes, so we're dropping a loop in central London, we could be doing 300 meters.
Wow, that's a lot. Going into the London Underground, you need to be careful doing that in London.
Don't worry.
Okay, next, we're racing through these. I don't know if this is, I actually don't know the monoblock versus split. I don't even know what I'm talking about. I'm literally mouthing the words, but I don't know what they mean.
Okay, so monoblock, the clue's in the language. It does what it says on the tin. Mono, one, block, one block. So a monoblock air-to-water heat pump has all the components in one box sitting outside. So it has both heat exchangers, it has the compressor, it has the expansion valve, probably got a circulation pump in it as well. So everything is in one device outside. In a split system, you have part of the heat pump outside, so normally the evaporator and the fans, and the rest of the technology is in a separate box inside, frequently referred to as a hydro box, but it doesn't matter. Yeah, different manufacturers.
So monoblock, it's all in the block. You've got to have something outside, really, but you're going to have to blow away the...
For air source, you've got to have something outside.
Yes. So monoblock is all of it outside. What is the split? What are most people getting when they...
In the UK, the market is dominated by monoblock.
Okay,
that's absolutely dominated by monoblocks. Air conditioning units, of course, tend to be splits.
They sit in the window, half inside and half out.
So you have a unit outside, and an air-to-water system and an air conditioning system, air-to-air system. The outside units look very similar. Monoblocks tend to be bigger because they've got more kit inside them, of course, than the equivalent for an air-to-air system. And the internal unit in air-to-air system, we're all familiar with the sort of cassettes you see at high level in offices and that sort of thing. That's very typical. We now have manufacturers making them low-level units, so they look much more like a sort of fan-assisted radiator or a fan-assisted night storage heater, that sort of thing. Mm-hmm. So it's more familiar, and you're delivering the heat at low level. Because that's one of our issues, is that delivering heat at high level as opposed to low level, whereas you're better off delivering coolant at high level because it falls then into the room. Heat you want to be able to rise.
Yeah. Right. Yeah, so that's the problem, putting the fan too high on the wall. So I just want to be clear though, so the monoblock would still have to have radiators or something inside. It's not like the whole thing is outside. It's got to have...
No, but all of the heat pump itself is outside.
Gotcha.
Yeah.
Okay, next is mini split. What's a mini split?
Well, I'm not sure I would necessarily make a distinction between splits and mini splits.
Okay,
it's just a small split.
It's a small one. Okay, that's fine. So some outside, some outside.
What we've now got is manufacturers are coming forward with scenarios where you have a single unit outside, but you can have multiple units on the inside where I think we're up to about, I think the biggest system at the moment will provide for 4 or 5 units on the inside. So you can do 4 or 5 rooms off a single external unit.
But this is the bit I want. That's on top of the radiators. You've got the
this is all out of the radiators. So if you're doing air-to-air, air conditioning,
okay.
Now you can have a single external unit, and it will drive up to 5 cassettes on the inside. So you can do potentially 5 rooms from a single unit outside. Okay. The problem is if you've got a 10-bedroom house, you're going to have a line of machines outside in order to be able to put a delivery unit in every single room. Because you've got to have something in every room.
You've got to have something in every room, but I assume that comes with every heat pump system, is a device in every room to heat.
Yeah,
otherwise it's not going to work, is it?
It does, but you've got to be able to get from the external unit to the internal units. And the connection in air to water is effectively water coming through the wall. In a split system, what you've got is refrigerant coming backwards and forwards. So
we need to come back to this because this is actually absolutely basic stuff. But I think we should come back to that. Okay, next word, bivalent operation.
So bivalent is normally associated with having a hybrid system where you have two energy sources, potentially two different fuels. So most people at the moment would consider a hybrid to be a combination of an air-to-water heat pump and a gas boiler. And the bivalent description says that you pick a bivalent temperature where you switch from one technology to the other. So by convention, you would say you run the heat pump while the air temperature is reasonably warm still. So you start heating when the air temperature hits sort of 16 degrees or so, and you run it down to the air temperature gets to maybe 5, and at that point you switch off the heat pump and you switch on the gas boiler. So that's a bivalent point. Can I confuse you a bit more? Covalent.
Next I've got covalent.
Good. So in a covalent scenario, you will continue running the heat pump, but you would support its output with the fossil fuel.
Gotcha. Okay.
So quite rare in the hybrid terminology that we're currently using today, where it is very much air source and gas. But in the noughties and the second decade of this century, we were installing systems which we didn't describe as covalent or hybrid, but they were essentially large ground source and oil. And we just allowed the ground source to run, and if we felt we needed to, we'd retain some oil capacity and just top the temperature up if we felt we needed to. And this was a way of avoiding having to change radiators. So if you're in a Grade 1 listed house where you can't change any of the radiators, it was one of the solutions.
Okay. So we've got hybrid heat pumps, which are kind of dual fuel, bivalent,
Switching between the two.
between covalent,
They want to work
together. I want to ask you about defrost cycle.
So all air source machines that are operating in the heating season, so this is now just units that are being used for heating, when you pass the air through the machine, we are taking out some thermal energy. So it's not quite the mechanism, but let's say we're reducing the temperature. Winter air in the UK tends to be very humid. So we're normally sort of 75, 85% humidity. As you pass that through the machine, we are taking out, let's say, 3 to 5 degrees. So we're reducing the temperature by 3 to 5 degrees. If that air goes in at 3 degrees and it's wet, it's humid, it comes out at 0. Air at 0 is dry. So where's all the moisture gone? What happens is that moisture starts to freeze up the heat exchanger, okay? And at some point, the detectors in the machine will say, I'm now so frosted, I'm less efficient than I need to be in harvesting energy, so I'm going to switch into defrost mode. And in defrost mode, that unit is now heating itself in order to defrost. It's just a heat exchanger.
What, like a kettle heats itself, or is it
different manufacturers?
Yeah.
Different manufacturers have different mechanisms for doing defrost. Some of them, they will effectively be taking warm water back from the house in order to put it through the heat exchanger. There are various mechanisms and ways of doing it. The key in the UK for successful heat pump deployment, and this used to be, I think, much more of a question than it perhaps is now with later technologies and more modern units, but there used to be a very significant difference between some machines and the way they treat defrost. Some have a lower propensity to defrost in the first place, and then a more efficient defrost cycle. And of course, in terms of total efficiency, when you're looking at SCOP or SPF, that includes the defrost cycle.
Right.
Okay. So you want a machine that spends as little time as possible in defrost mode.
I think we've done enough words for one day. It's a lot to take in. And I'm studying French. I know that you can only learn so many words in one go, like one word at a time. That's enough. But look, you, dear listener, may have words that you don't understand about heat pumps. There are lots I don't. And let us know. We'll try and answer your questions. You can email us at happyheatpumppod@gmail.com. Of course, you can leave comments. We get loads of them on YouTube, and we do like to read them. And do join us next time.